Welcome back, everyone. Today we'll be discussing Leetcode question number 863, which is all nodes distance k in binary tree. So let's read the question. Given the root of the binary tree, the value of target node target and an integer k. So you will be given the root of the binary tree. Another one will be the target, and another one is the k. So you have to return an array of values of all the nodes that have a distance k from the target. So it is saying that you will have to return, means you will be given a target node, and you will need to return all the node that is at the distance k from the target node. So let's see the example test case. So example, yeah. So this is the tree, and in this case, 5 is given as the target, and what is k, and yeah. So target is 5 and k is 2. Target is 5 and k is 2. So what you have to do, you have to return all the nodes that is at distance k, which is 2, means at a 2 distance from this 5. So you can see that this 7, 4 and 1 is at distance 2 from this 5. From this 5, this is 1, this is 1, and this is 2. This is at distance 2. And again, this is a distance 1 and this is a distance 2. So you have to return this all this node, which is at the distance k, which is 2. So 7, 4, 1 will be the answer in this case. So let's discuss the approach. What we will do, we will create a map, and what that map will contain. That map will have key as the child and value as the parent. Means if 5 is the child, its parent is 3. So in my map, it will be stored like this. 5 is the child and its parent is 3. Again, 1 is another child and its parent is also 3. In this way, I will store parent of each and every node. 3 is the root node, so it won't have any parent. So for 6, 5 is the parent. For 2, 5 is the parent. Again, for 7, 2 is the parent. For 4, 2 is the parent. And 1 we have done 0. For 0, 1 is the parent. And for 8 also, 1 is the parent. We will store in this way. We will not store the node value. We will store the node. So map will be of type tree node, comma tree node. Okay, so after storing, and for storing this in a map, we need to traverse the tree. So you can use any traversal for doing that in order pre-order or post-order. After storing the parent, uh, we can do BFS or DFS. So I'm doing BFS. So I will start BFS from this node 5. From this node 5, I will keep a set, unordered set for tracking the node that I have visited. Okay, if I will start from this, I will visit this node, and visit this node. Means all the node adjacent to the 5. So I will do BFS. So I will need a queue. I will need a queue. And in that queue, I will push all the adjacent nodes. And I will, I have, I have visited this 5. So I will store this 5 into my set. Let it, let's separate it. And this is set. And this is queue. So I will start traversal from this 5. So I will push this into my queue. I will start the traversal, put this in my queue. There is a 5. So I will take this 5 out and check its whether left and right child exist or not. Yeah, we will also need K or K. In my queue, I will have a node along with the K. No, not only node will be enough. Not K is not required. So we can keep the K globally. So I will take this 5 out of the queue and check its left. Uh, yeah. So I'm processing this level. If I will process one level, I will do a K minus minus. So I have taken this 5 out. I will do a K minus minus. So currently K is 2. So if I will do minus minus, K will become 1. Okay. Now I will check the left and right child of the 5. So it is 6. Left child is present, so I will push it into the queue. Right child is also present. I will push into the queue. And I will also check the parent. And before pushing, I will check whether that node is visited or not. Means whether it is present in our set or not. Okay, so if it is not present, then we will push into the queue. And if it is present, then we will not push. So we show that 6 and 2 are not present in our set. And parent, which is 3, which is also not in our set. So I will push this 3 into my queue. And after this, I will insert this 5 into our set that I have visited this node. Now, uh, the next level. Uh, and sorry, now the next element, which is 6 in the queue. I will take this 6 out. So this is 6. And I will check whether its left child are present or not. So no left child and right child are not present. I have started another level processing. So I will do a K minus minus. So K will become 0. Yeah, so K has become 0. Uh, now, now 6 has no left and right child, but it has a parent. So I will check whether we have visited this or not. So it is present in our set. So it is already visited. So we will not add it to our queue. Now I will take the next element in the queue, which is 2. So 2, we will see uh, the left child and right child. So left is 7. We will check whether it is present in our set, means we have visited or not. So it is not visited. So we will add it into our queue. 7. 7. Also, we are doing a level order traversal. So the current level that we are processing is till here. Okay. So this is one level, 6 to 3. 6 to 3, yeah. And this was another level. Okay, so we took out 2. So 2 has 7 and 4. So both are not visited. So we will push into the queue. And we will check the parent of 2, which is 5. So 5 is already visited, so we will not add. Now we will take out the next element, which is 3. So we will check the left child of 3, which is 5. So it is already visited. We will not push into our queue. And the right child is 1. So it is not visited. I will push it into my queue. Okay. So we have completed the traversal of this level. Now we will start the next level, traversal of next level, which is 741. But we can see that before starting the next level traversal, our k is 0. Means we have reached the level that we want. So we will not move further. In the while loop, in the level order traversal while loop, where we will have condition, where we check whether queue is empty or not. There only we will add the condition for this k. This k should be greater than 0. If it is 0, then we have reached our level. So k is 0, so we will stop the traversal, and whatever is left in our queue is our answer. You can see that 741 is our answer. So this was our logic. So time complexity for this will be O of n, as we are traversing all the nodes where n is the number of nodes, and we are traversing all the nodes. So time complexity will be O of n. Now let's discuss the code. Yeah, so this is the this function create store parent. This will do a traversal and store the parent in an ordered map. This is simple tree traversal, and what it is doing, it is checking if root left is there, then in the map it is adding root left along root as the parent, and again calling the store parent and recursively and processing for the child nodes. The same way it is doing for the right also. So this function will store the parent of each child in the tree, and that will be stored in this map. Now let's see the next function. Yeah. So this is the map. This is the map that I declared, and call this function store parent. So this will store the parent of child node into this map. After that, I have taken set that will track the visited node, and I have taken queue for the level order traversal. And at the beginning, I have pushed the target, starting from the target. And yeah, so doing the level order traversal, finding the n, which is q dot size, and I'm doing a k minus minus, and running a for loop for that level, and taking out the node and removing it from the queue, and inserting it into the set for tracking purpose, whether it is visited or not. And I'm checking whether the node left of the node exists, and it is not present in our set, means it is not visited. Then only I'm pushing it into my queue. Doing the same for the right, checking whether right exists and it is not visited, and pushing it into the queue. And huh, and also uh, checking the uh, means visiting the child, and after that visiting the parent taking out the parent of that node, means the current node that I'm taking out the parent and checking whether parent is not null and parent is not visited. Then also I'm pushing it into the queue. So in this way, the loop will move ahead, and when the k will become 0, so whatever will be left in the queue will be our answer. So I have taken a vector and run a for loop till the queue is not empty, and pushing whatever it is present in the queue into our resultant vector and returning that. So let's run this code. Yeah, it passed all the given test cases. Let's submit it. Yeah, it's passed all the test cases. So thank you for watching. Do like, subscribe, and share.